Question number 2. Okay, this will be published on 17th of December 2024. Okay. This was 7 marks, so I have put it for 7 minutes. Let me try to solve it within 7 minutes. Okay. So now, outline what is meant by escape speed. What do you mean by escape speed? It is the minimum speed required to escape from the gravitational field of a planet. This is what you need to write. Okay, some of you can also write something like speed required to reach infinity. You can also write this definition. Both are right. Okay, then a probe is launched vertically upwards from the surface of a planet with a speed v equal to 3 by 4 times v escape. What does it mean? It means you are not supplying something like the speed equal to escape, but instead 3/4 of it, which means will the probe escape from the planet? It will never escape from the planet. It will return back to the planet itself. Okay. Now, what is v escape? Usually, if a planet has a mass m and then radius r, then this v escape can be written as square root of 2gm divided by r. Okay, this is known to us, right? The planet has no atmosphere. Why is this line given here? Because it means that there is no friction. Okay, there is no air resistance. Despite determined in terms of the radius of the planet r and the maximum height from the surface of the planet reached by the probe. Now, what is the question once again here? So you have a planet of radius r and mass m over here. Now you are launching a probe from here so that it goes to some height, okay, and then maybe it will return back. It can go only to a maximum height over here. He is asking you what is the maximum height. Okay, don't use the projectile motion equations because we are talking about gravitation here. Now, how do we solve it? See, always remember, whenever the gravitational field is changing as we keep on going upwards, then your kinematic equations will not be helpful. Why? Because the value of g is not a constant, right? If I throw a particle and it comes back to my hand, I can always use equations of motion. You can put v square equal to 0, u square you can have, and you can write that one. But unfortunately here, the value of g is not going to be a constant. It is going to vary over here, right? So therefore, now what should I do? When things are not constant, especially here, kinematics should not be used, and you should use conservation of energy. Now, how do I use conservation of energy? Energy when you throw, what was the energy here? Energy when it reached, what was the energy there? Simple. Okay. What is the initial energy here? Initial energy at this point is nothing but you are throwing with a kinetic energy half mv square, and the object also had a potential energy, otherwise it will not be stuck to this planet. So the potential energy is minus g mm divided by r. Okay. Now when it went here, what happened? The velocity kept on decreasing, speed kept on decreasing, and it went to a maximum height. It did not have any speed, right? Velocity becomes 0, or speed becomes 0. So which means here kinetic energy is 0. So E final I will write 0. And what was the potential energy? Potential energy, let me consider, instead of considering this as h, I'll consider the whole height as h over here. Whole height as h. For some reason, to make our calculations more simple, I'll take this as h over here. So this I can now say this is minus g mm by h. Now what does conservation of energy tell you? E initial should be equal to E final. You just equate this. So I get half mv square minus g mm divided by r should be equal to minus g mm divided by h, right? I need to find the value of h. Let us do this. Now what is v here? We got here as 3 by 4 times v escape, which means I have to now substitute this here, which will tell me 3 by 4 into root of 2gm divided by r. This is the value of v. Let me substitute this value here. So which means I get half m into, for v I'll substitute this 3 by 4 whole square. What will become? It will become 9 by 16. And this one, if I square, the square root will go away. So this becomes 2gm divided by r minus gmm divided by r is equal to minus gmm divided by h, right? So now let me simplify this a little bit more. So this half and this 2 goes away here. So I get this as 9gm, there is one more m missing here. Where is it? This m is here, yeah. gmm divided by 16r minus g mm divided by r is equal to minus g mm divided by h. Now what is common? G mm is common. So just cancel all of them. So what do I write now? So if I simplify this, I get this as 9 by 16r minus 1 by r is equal to minus 1 by h, right? Now can you simplify it further? I'll write it down here. So this should now be this r common here. I'll write here 1 by r into 9 by 60. Oh, I need to do this also. Okay, I'll not write here. Is there space available here? There's some amount of space. Okay, I'll write it here because I need to continue with this problem, right? So I'll write 1 by r into 9 by 16 minus 1 is equal to minus 1 by h. So what is this 9 by 16? This should be 16. I take the common here. 9 minus 16 by 16, which should be equal to minus 7. Minus 7 by 16r should be equal to minus 1 by h. This implies h should be equal to 16r by 7. H should be equal to 16r by 7. But read the question once again. Determine in terms of radius of the planet the maximum height from the surface of the planet. Now what is that height we have taken? We have taken this full height, right? But what do I need? I only need this height over here. So what should I do? I should subtract this value of r, right? Okay, remember this height is from the center of the planet, and this height, what is the question here? The question is asking me only from the surface of the earth what is the height. So I need to find this height over here. Okay, so therefore what should I do? I should subtract this r from this height, right? So though I have got something here, but this is not the final answer. So therefore the height which he is asking should now be equal to 16r by 7 minus r, which should be equal to 9r by 7. So if you look at the marking scheme, you get the same answer. The answer is 9r by 7. Okay, let us move on to the next problem. Then the total energy of a probe in orbit around a planet of mass m is given here. Okay, minus gmm by 2r, where m is the mass of the probe and r is the orbit radius. A probe in low orbit experiences small friction force. Okay, he says, okay, while there is a probe moving on into this, okay, there is a small frictional force over here. Okay, such is the effect of this force on the speed of the probe. What will happen to the speed of the probe if there is a frictional force? If you remember, I told you in the beginning here itself that in this question, it says, where is it? It says here that the planet has no atmosphere. What does it tell you? It means there is no frictional force. But now you are introducing the frictional force. In that case, what will happen? So as a result of this, when there is a frictional force, now let us say this is the planet, this is the probe over here. Probe is happily roaming around here. Okay, it's just orbiting like this. But if there is a frictional force, what will happen? It will lose energy. See, this is for 3 mark. Okay, you should write at least 3 points over here. So it will lose energy. First one. When it loses energy, then what can happen? The gravity will now try to attract it like this. As a result of it, it will now come closer to the planet over here, right? This is the first point. Second one is comes closer to the planet. You can write like this, or you can also write radius of the probe decreases, right? When radius of the probe decreases, what can happen? Okay, now he is asking you to find out the orbital velocity. Now what is orbital velocity given by? This is given by root of gm by r, right? When r decreases, then 1 by r increases, right? This gm you cannot alter because m is the mass of the planet, g is gravitational constant. You cannot do anything. It only depends on r. So it's inversely proportional to r here. So as a result of this, when r decreases, what will happen to orbital velocity? V will increase. Right? This V increases with this, and as a result of this, you can say that the velocity of the probe will increase. What is this asking? Suggest the effect of this force on the speed of the probe. Finally, we have visited this part, right? So with this, we come to an end to this problem. Tomorrow we will see the next problem. Thank you.